All right, so we just wrapped up 3.1. 3.2 is going to look something like this. You had a few different types of things going on there. You had to look at some basic graphs. You had to know the shapes for those graphs. And then we talked a little bit about the vertical line test, and we also did piecewise functions. Okay, so I'll talk about those. First, let's see, so here's 3. Don't want to use purple, that's hard to see. 3.2 was graphing. And so first you talked about your 6 basic shapes: y equals absolute value of x, y equals x squared, y equals x cubed, y equals the square root of x, y equals, I think I'm forgetting one. I know there was this one, square root of 1 minus x squared. Okay, we got parabola, cube, square root, absolute value. I'm missing one, but it'll probably come to me. Just a second here. All right, so let's talk about the shapes. You already know what y equals the absolute value of x looks like. It's simply a V shape. Okay, you should be able to figure out exact points, meaning that not only should you know the shape, but you should know that if you plug in 1, your output is also 1. If you plug in 2, your output is positive 2. Similarly, if you go to the negative direction, negative 1 gives you positive 1, and negative 2 gives you positive 2. Okay? The domain and range you can look at negative infinity to infinity, because domain is your x values, range is your y values. You can see that the x's will always go to the left due to this function expanding to the negative direction and also to the positive direction. So the domain is going to be all real numbers. The range now, range is the set of y values. So if you look at this picture, you can see that it's never going to go any lower than this point right here, which is where y equals 0. So we'll say that from 0, and it does go up towards infinity. That would be your range. Okay? So now y equals x squared, similar. Again, you should know several points on here. So here's the shape. It's the U or parabola shape. You should know that if you plug in 1, you get 1. And if you plug in 2, you get 4. Okay, and you can do the same on the left. Negative 1 is positive 1. If you plug in negative 2, you get positive 4. Okay, and the domain and range, even though they hit the values not exactly the same as the absolute value function does, it has the same shape. So the domain is from negative infinity to infinity, and you can see that this will never go below 0. So we go from 0 to infinity. Oh, and I just remembered the 6th graph that you guys need to be very, very good with. Okay, x cubed. So now that you guys have seen those, I'm going to erase these. You can certainly go back and rewind if you need to. Okay, so for x cubed, it's on the right side it looks like half of a parabola, and on the left side it looks like a parabola that was flipped upside down. So it looks something like this. The reason for that is, you guys know that if you cube a number, for instance 0 cubed is 0, 1 cubed is 1, but now if you plug in 2 and cube it, you get 8. Okay, so here are some points that you should know. But now when you plug in negative values, like negative 1, you get a negative output, because negative 1 cubed is negative 1. And if you go to negative 2 and plug in a value, you get negative 8. Okay, so that's why we have this S shape. All right. So now the domain and range you can kind of look at it by inspection here. You can see that we're always going to have values go to the right for x, similarly to the left. No restrictions there whatsoever. And it's pretty easy to see that the range is similar. Remember, range is y values, looks like this function will keep on going towards negative infinity and shoot up towards positive infinity. Okay, so that would be the domain and range. Okay, so now for the square root of x. Okay, that looks something like this. And again, you should know some nice points. Be able to graph that quickly, know the domain and range. If you ever forget, it's not very hard. Plug in 0, you get 0. Plug in 1, you get 1. Plug in 4, that's another nice value to plug in. You get 2. Because the square root of 4 is 2. Square root of 1 is 1. Square root of 0 is 0. And obviously you cannot plug in any negatives because you cannot take the square root of a negative. And that's how you get the domain. You can plug in 0, so that's going to be a closed circle or a bracket. So from 0 to infinity is our domain. Our range, again, look from bottom to top. The graph never goes down below the x-axis. In fact, the lowest it gets is right here at y equals 0. And even though it looks like it's slowing down, it does keep rising ever so slowly. So it will go up towards positive infinity. So there's your domain and range. Okay? Y equals the square root of 1 minus x squared. So let me go right up here. It's a half circle, radius 1. Okay, we really haven't worked too much with that yet, but essentially it looks like this. If you imagine this equation, if you square both sides, you get y squared equals 1 minus x squared, and certainly you could move the negative x squared to the other side, so you get x squared plus y squared equals 1. And you guys know that this is the equation of a circle centered at the origin with a radius of 1. Okay? So that's where we get this shape. The reason that we only have half of it is because we're talking about a square root, and a square root can only be positive. Okay? So that's why we get just the top half. If I made this a negative sign, then we would get the bottom half of the circle. If I put a plus and a minus in front of it, now we're talking about the entire circle. Okay, but the shape that you guys need to be very comfortable with is recognizing the square root of 1 minus x squared is a half circle. And the domain and range, obviously from negative 1 to 1, because x can't go any lower or higher than those. And the range, the lowest value we see on the graph is 0, the highest value, definitely not infinity, sorry. The highest value for the graph, the maximum, is 1. Okay, so there's your range. All right, so now y equals 1 over x. I'll just do that right over here. So this is the sixth and last shape that you guys need to know. You guys have already done this in Algebra 1. Just make sure you don't forget it. This is what we call the reciprocal function. Okay, some nice values. You can easily calculate them. It's not very difficult. If you plug in 1, 1 divided by 1 is 1. 1 divided by 2 is a half. 1 divided by 3 is a third. Okay, if you plug in 0.5 or 1/2. Okay, so if you plug in positive 1/2, 1 over 1/2 would be the same thing as multiplying by 2. So you get positive 2. Okay, and that's how you get this shape. Okay, this graph will never cross over below the x-axis because as you plug in higher and higher x values, this just gets smaller and smaller. It doesn't become negative. Okay, so that creates what we have, what we call asymptotes. So we have an asymptote at y equals 0, meaning that this line will never go past the y equals 0 line. We also have an asymptote at x equals 0. Okay, meaning that this is not going to cross over in that direction. Okay? The reason we have an asymptote at x equals 0 is because it doesn't make sense to do 1 divided by 0. So you're never going to find the graph ever having an output for x equals 0. That's what creates this vertical asymptote. If you plug in negative values, you get the exact same shape that we have here, just in the third quadrant. So it looks something like this. Okay? Domain and range. You can kind of see that it does go towards negative infinity in the x direction, but we have a gap we have two separate pieces here, so it does get very, very close to 0. Okay? In fact, it just basically skips over it. So we do negative infinity to 0, and then from 0 to infinity as our domain. Okay? So it does go to negative infinity, and whoop, right here at x equals 0, there's no graph, but it does pick right back up after that, and it goes over to positive infinity. If you rotate your head and turn it sideways, you can kind of see it's the same thing in the range. So it's the exact same domain and range. Okay? So those are the 6 basic shapes that you guys should know. You should also be able to find the domain and range from a graph, which we kind of did here with these 6 basic shapes, but what I'll do is just one example of a goofy graph that you should be able to find the range for. Okay, so for instance, let's say I had a graph that looks something like this. So here's x, here's y, and 1, 2, 3, let's say alright, so let's say we have something that looks like this. So let's start down here, and maybe this thing looks something like that. And so let's say we have a graph that looks something like this. Okay, to find the domain, it's the same idea. You go from left to right. What's the lowest x value that you see on your graph? Well, since there's no arrow, the lowest x value I see here is at x equals -3. So far I know my domain starts at -3, and then I keep going until I get here at -1. Right now there's an open circle there, which makes it a 1 with a parenthesis. Okay, but luckily for us, if I look right above there, I have a closed circle for this other section. Okay, so instead of having this as a parenthesis, we can pretend, well not pretend, so far we go from -3 to -1, we think maybe there's a problem here, but we do actually have a value, we have an output at x equals -1, so we're okay, and now we can see that this graph keeps going, there's an arrow there, so it goes from -3 to infinity. Okay? If you were thinking maybe that the domain was from -3 to 0 with an open with a parentheses there, and then union bracket -1, I'm sorry, from -3 to -1, and then bracket -1 to infinity, okay? This is a redundant statement because this is the simplified version of this, okay? So right here you see that you have an open circle on -1, a closed circle on -1, so essentially it kind of bridges the gap and connects those two pieces together. Okay, so we don't need this. This is the best way to describe it. Okay, so now let's look at the range. The range is y value. So we start at the bottom. The lowest y value I see is here at -2. And then I go up, and I see that there's a problem right here. There's an open circle, and I look around everywhere at -1, and I don't see anything else. So I know that I'm not going to actually hit -1. So we're going to close it, stop it right there with a parentheses, and then let's see where I pick up the function again. Looks like I'm skipping from -1 to 0, there's nothing there. But then right over here you can see that it's getting really, really close to 0. So essentially, maybe an asymptote, kind of like the 1/x graph. So we can say that it'll get closer to 0, but it doesn't look like it's going to cross over or actually hit it. So we're going to say 0 with a parentheses, since it will never hit 0. And then the highest value for y looks like it's 2. Okay? So this had to do domain and range from looking at a graph. Let me see how much time I'm at. Okay, let me stop it there.